guys, this is chapter 3, linear functions, lesson 3-4, direct variation. And truly, direct variations are the smallest of little baby linear equations. They are y equals kx. K is usually a number. And they always pass through the origin. They always cross through 0 and 0. And so there's never any plus 3 or minus 2 or anything else that happens to be written out to the side of the equation. It's just y equals a number times x. That number times x, k, is called a constant of variation or a constant of proportionality. And if you will remember from the last lesson, when we learned about slope, slope is the change in y over the change in x, or y2 minus y1 over x2 minus x1. Another way that we can talk about slope is to talk about the rise over the run. So remember, the change in y is the up and down direction that we're going, and the change in x is the left to right. And so if I was looking at, let's say, a triangle like we drew, then this would be the run, and this would be the rise, and it would tell us the slope of this line when we put it into the formula like that. So all of these are also the same as k, and this is an example right here, y equals negative 6x. This is a direct variation. So direct variations are just situations where every time x goes up, y goes up also. So maybe I would say I'm going to eat more and more and more cookies, and so therefore my weight is going to go up and up and up and up. Or maybe I'm going to jump up into the air, and so therefore my altitude on the up part of my jump is also going to go up. So whatever relationship we have going on here is not only linear, but it is direct. If x is going up, y is going up. If x is going down, y is going down. So let's work a few problems and show you how some of this works. If I'm looking on page 185, then I could talk about number 1, or let's look at number 1. And it says, name the constant of variation for each equation. So basically we're talking about slope. Then find the slope of the line that passes through each pair of points. And so truly, they're going to be the same thing. If I'm looking at this line, I notice that it gives me one point here, and it also lists one other point. Notice that it does go through the origin, so it is a direct variation. And I'm going to do my little formula, my y2 minus y1 over x2 minus x1. Solve that, and I'm going to get negative 4 on the top, positive 5 on the bottom. And so my slope is negative 4/5, and my constant of variation is also negative 4/5. I could write this equation, y equals negative 4/5 x. It's a very simple little equation. In number 3, I have a direct variation equation, y equals negative x. That would be like negative 1x, and it says to graph it. And so if I were actually going to graph this, I would know that I am definitely starting at the origin. And since my slope is negative 1, that means that for every 1 I go to the right, I am going to go down 1. So my rise is negative 1. That means go down 1. And my run is always going to be 1 if I have a whole number, because I could put anything over 1. So I could do the same thing. I could go over 1 and down 1, over 1 and down 1, and then I could connect my lines as best I can there, and it would look something like that. A fun one to graph, number 4, y equals 3/4 x. Since this is the rise and this is the run, whenever you have a fraction, it's actually very simple to graph it. So since this is a direct variation, there's no plus anything out here at all. I'm just going to start at the origin and go rise 3, 1, 2, 3, run 4, 1, 2, 3, 4. And I'm going to actually run off of my little graph here, but that's okay. Notice that I have an uphill slope for a positive 3/4. All right, look at number 7. It says, suppose y varies directly as x. Whenever you have that sentence, suppose y varies directly as x, you can assume that. Write a direct variation equation that relates x and y and then solve. Okay, this is fine, except that I need a number to plug in instead of the k. So I have in this problem y equals 15 and x equals 12. It says if y equals 15 and x equals 12, find y when x equals 32. So there's what we're trying to figure out. And so what we can do, there's a couple ways to look at this, but what we can do is we can plug in these two numbers that we know go together into this equation. So we have 15 instead of y equals k that we don't know times 12. And so I'm going to solve this by dividing by 12. And k equals, I can simplify this because 3 goes into 15 5 times and 3 goes into 12 4 times. And so I know that k is going to be 5/4. I could rewrite my equation now to be y equals 5/4 k. Whoops. X. And then, since I want to know what y is when x equals 32, I'm just going to plug it in. Y equals 5/4 times 32. Feel free to use your calculator. Y equals 40. Okay. Are there other ways to do that? Yes. So what if I wanted to talk about the fact that we know it's a direct variation. It goes through 0 and 0. We also have the point 12 and 15. And so I could do this. 15 minus 0 over 12 minus 0 equals 15 over 12, or 5/4. So that's be another way to look at that. Let's look at number 9, the word problem. It says you find that the number of messages you receive on your message board varies directly as the number of messages you post. So we know that we're going to have something like this. Okay, the number of messages you receive on your message board varies directly as the number of messages you post. And it says when you post 5 messages, you receive 12 in return. Okay, so that'd be like 5 here and 12 here. So we have a 5 that goes with a 12, and we need to solve for k. So we're going to divide by 5. And we have that k equals 12/5. That's not a very nice number. But y equals 12/5 k. I did it again. X. And it says write a direct variation equation. So that would be it. That's A. And then B says find the number of messages you need to post to receive 96 messages. So I'm going to plug in 96 for y here. So I'm going to multiply this by 5/12 to get it to cancel, see? But I have to do that over here. For some reason we are not. There we go. And so we can use a calculator because or we can just cancel here. This is 8, and 8 times 5 is 40. So we know that we need to post 40 things to receive 96 messages. Okay, jump to number 24, and we'll do one more of these if there's time here. If y equals 6, when x equals 10, and suppose y varies directly as x, find a direct variation equation. And then we're going to find x when y is 18. So we just plug these numbers in. 6 equals k times 10, divided by 10. We can simplify 6/10 to be 3/5. And we can rewrite our equation as y equals 3/5 x. Then we want to know what x is when y is 18, so we just use our equation. Multiplying by 5/3, because reciprocal will cancel there. And I get 30, x equals 30. So that's how those work. Every time you see suppose y varies directly as x, you're going to have y equals k times x. You've just got to find out what k is. And very often, really, the only thing you need to do, you can plug it in the way I've been doing. You can also put the y over the x. If you, let's see if that would have worked in the last one. The y over, the y over the x. Yeah, definitely. 6 over 10 equals that. So y over x is going to be our constant. And actually, y equals kx. Look what happens if we actually solve for k. Y over x equals k. Aha! All right, so I'll let you work on some problems and practice that.